I can get your attention back up here. How do we find the axis of symmetry? Go ahead, Dan.
Opposite of B over 2A.
Okay. Opposite B over 2A. Opposite of B is? What do you got, Emily? Negative 10. Good. Remember, this is our B term. Okay. And 2A? Dylan?
Negative 4.
Good. Yeah. 2 times negative 2. That's our A term. So that gives us negative 4. And negative 10 over negative 4 is? What's that? 2.5. Okay. Good. We get this nice decimal there. 2.5. So we go y equals negative 2 times x squared plus 10 times x minus 7. And we're going to put that 2.5 in for our x value here. And that's going to end up giving our y value of the vertex. So right now we found the axis of symmetry is x equals 2.5. That also tells us the x-coordinate of our vertex is 2.5. And then we go ahead and crank that out and we get the y value. So 2.5 squared.
6.25.
6.25 times negative 2.
Negative 12.5.
Negative 12.5. Good. And then 10 times 2.5. Move our decimal 1 over, right?
25. 25.
25.
Oh, never mind.
And then subtract 7. So 12.5, negative 12.5 plus 25 minus 7.
It's a number.
It is a number. Well, 12.5 is half of 25, so that's positive 12.5. What's that?
25.
Good. 5.5. All right. Any questions on it? You guys had it. How many had that answer? Good. All right. So when we're starting out any quadratic, whether it's graphing or just finding the axis of symmetry vertex, or a lot of times we'll end up using this information of the vertex to find a maximum or minimum. We're starting this out. Usually x equals opposite of b over 2a is a good starting point. Okay? So let's go ahead and turn to the next page. All right, let's take a look at number 8 this time. Go ahead and compare with your neighbor what you got. What's the first thing you did? KK? Identify ABC. So A equals, B equals, and C equals. So Lindsay, what's A equal? 2? Good. What's B? And C? Negative 3. Good. Well done. So there's C, there's B, and there's A. Okay, so we have it in standard form, ABC. All right, and so from there, what's the first thing we have to do in order to graph this? Emily? Yeah, opposite of B over 2A again, right? Same thing we just did over on the other page. That was to set us up there. So opposite of B over 2A. So Kalina, if you do x equals opposite of B over 2A, what'd you end up with? So negative 8 over 2 times 2, or? Good. Good, and we get negative 2. So x equals negative 2. So we use that. That's our axis of symmetry. So if we went down to our graph and we went to negative 2 on the x-axis, we'd be able to put our axis of symmetry in. Okay, put that dashed line in there. What other value did that just give us? What's that, Charlie? And not your x-intercept, but your x-coordinate of your vertex, right? So this is our negative 2. Okay, so we've got negative 2 there. Now remember, this table right here doesn't give us a work area. You recall from earlier in the chapter we did tables like this. What went in here?
The equation.
Yeah, the equation, our rule. 2x squared plus 8x minus 3. All right? And so we've used our negative 2 now. That's what we had here. We kind of put that in the middle. When we put negative 2 in, this, remember, gives us that opportunity to show our work. So negative 2 squared is 4 times 2, 8. Negative 2 times 8, negative 16. And negative 2, well, we don't multiply. There's no x here, so we just bring down that 3. Okay? What's 8 minus 16 minus 3? Negative 11? All right. Very good. Okay? So, what do we put on these sides? Okay. Go ahead.
Go down for negative 3, negative 4.
So you're going negative 3, negative 4?
Yeah, I go down the down.
Okay. So you're going this way.
Yeah.
How many put negative 1 down here? Okay. It's okay. It doesn't matter which way you go. All right. Now I have those values. Oh, that's not much of a straight line. That's okay. Hey, I'm going to add one more. That should be 0. Okay. I think I'm going to take off 2 of these points here. We only required 5 earlier in the semester, so we're going to do 5 here. So negative 3 squared, 9 times 2, 18. Negative 3 times 8, negative 24. And bring down negative 3. What do we get? Negative 7? Negative 9? Oh, we're disagreeing. So negative 6 minus 3 is negative 9. Good. Okay, so right now, what should this value right here be without doing any math? Haley, what do you think? This value right here should be what? Yeah, it should be negative 9. Why should it be negative 9? KK? Good. Negative 2 is our axis of symmetry, so it's a reflection. This should be negative 9. So if we did the math, negative 1 squared is 1 times 2, negative 8, and 3, and that gives us, good, negative 9. Well done. How about 0? When I put 0 in, notice I could pick negative 4 or 0. They should give us the same value. When I have 0 in for x, what value does that give me? It does give us negative 3. What's that special name for that point? Vertex. When x equals 0, so let's look at our graph.
Y-intercept.
Good, yeah, it's our y-intercept. When x equals 0, we go to negative 3, that's where our graph's crossed as a y-axis. That's our y-intercept. So in your table, just like we say this is our vertex, you may want to just say y-intercept right here. These are special points. Okay? And if we do the math, this better be negative 3 as well. Okay, so 16 times 2, 32. And we get negative 32 and negative 3. That zeroes out. Good. Okay. Not the neatest table, but there we go. All right. So do I need to fill out this table then? No, don't need to. I've got it up here. Okay. All right. So let's graph our points. So we've got our negative 2. Whoa, man. It's way down there. Shee-many. Okay, and then we got negative 1, negative 9. All right. And we've got our 0, negative 3. And these should be reflections. Okay. We get our U shape at the bottom here to our parabola. And off we go. Boy, that was a bad curve there. Okay. All right. So, how many of you have a graph that looks like that? Okay. Everyone point to your neighbor where the y-intercept is on it. Okay. So, got our y-intercept right here. Hopefully that's what you pointed. I'm going to extend my graph now. Okay? In fact, if I were to figure out the next points, I would know where they go up here. These points right here, they have special names. What are those called? So this is where we're trying to tie what we did in chapter 10 to chapter 7. They are called our roots. Good. They're called our roots. There's another name for them.
X-intercepts.
X-intercepts, yes. We also call them solutions. Okay, so right here they're saying, what are the x-intercepts? What are the roots? What are the solutions? Okay, and so we can't, I mean, that's kind of estimating. In fact, we don't even know if we drew this line right because I didn't plot that other point up here. So we could kind of guess. We say, well, it looks like it's probably like 0.5 maybe, and 2, 3, 4.5. Okay, what tools did we have to figure out the x-intercepts? There are 3 ways that we had this chapter, or that we've just studied. What's one?
Square roots.
Square roots. What's another? Yeah?
Quadratic.
Quadratic formula. Good. What's another? KK? Factoring. Good. Okay, so we go all 3 of those. All right? So right now, let's figure out if we can factor it. That's the quickest way, right? So if I have 2x squared plus 8x minus 3 equals 0, 2 times negative 3 is negative 6, and we have our 8 down here. 2 things to multiply to make negative 6 and add to 8. 1 and 6. 2 and 3. Do any of those work? No. So what's that mean?
You cannot factor
It
it.
means you can't factor. We've got to do the quadratic formula. All right, I want everyone to try the quadratic formula right now if you haven't done so. So you'll notice that I used a separate sheet of paper here. Sometimes it's nice to have that extra piece of paper. So the opposite of b plus minus square root of b squared minus 4 ac all over 2a. That's what our x values are. So opposite of b here, right? There's our b. There's our a. And here's our c. Opposite of b, we got negative 8 plus minus the square root of, what goes here?
8 squared.
Or? No, it's 64. Minus 4 times 2 by, good, negative 3. And then we want, remember, this is the piece we're really concerned about right here. That's where some of us were making mistakes. So 2 times a is 2 times 2, or 4. What did this equal right here? 24? Yeah? All right, 24. Positive, right? Okay, so then we've got that equals negative 8 plus minus 64 plus 24 over 4, which is equal to negative 8 plus minus 64 and 40 or 24. Good, I heard that. 88 divided by 4. Now some of us, once we got there, we struggled a bit. Right? That's where we break it apart. Negative 8 plus root 88 over 4, and negative 8 minus root 88 over 4. So what's that give us for the top? You got that one? KK? 0. What? 0.35, okay? How about the bottom? Yeah.
I got
Negative 4.4. Anyone second that? Okay, good. So 0.35 and negative 4.4. So we got 0.35 and negative 4.4. If we look at our graph, that looks like it could be about a 0.35. And this looks like 1, 2, 3, 4.4. Well done. All right. Kelly, what you got?
I don't know how you got 0.35 because when I plugged it in.
Okay, let me look at your calculator with you, okay?
Negative 4.
When you're plugging this into your calculator, make sure you close that parenthesis after the root 88 if you're going to put in that divided by 4 right afterwards. Otherwise, enter negative plus root 88, negative 8 plus root 88, enter.